Hi, this is Ronald Sapp, FTH 212. This week 2 assignment. Today is February 27th, 2026. Let's get in. Alright, so today I'm going to explain several important parts of this PSA dagger. I will describe what each part does, the critical dimensions that matter most, and what could happen if it fails, and the normal wear you might expect over time. First, let's go to the locking block. This is going to be one. I'm going to go to the locking block trigger spring right here. The striker spring cup. Alright, we got that right there. The spring loaded bearing right here. Alright, and extractor plunger. And the rear rail. Alright, so the first is the locking block here. Alright, the locking block supports the barrel and helps controls the locking and unlocking of the slide during fire. The most critical dimensions are the height and the width of the locking surfaces. The most critical dimensions are the height and the alignment of the crosspin holes right here and here. All right, and the angle of the engagement surfaces that contacts the barrel lug. If these dimensions are slightly off, the barrel may not lock up correctly. That can cause poor accuracy, failure to go into battery, or even excessive stress on the frame over normal use. The locking block may show finished wear on the contact surfaces, and slight peening where the barrel lug impacts it. All right, so next we're going to go to the trigger spring right here. Let's say the spring helps reset the trigger after each shot. The critical dimensions include the wire diameter, coil spacing, overall length, and proper hook shape at each end. If the spring is too weak, broken, or stretched, the trigger may not reset properly. That could lead to a dead trigger, which means the gun will not fire until manually reset. With regular use, trigger springs can weaken over time or break at the bend points due to repeated tension. All right, now we're going to go to the, let's see, very small, the striker spring cups. They're a small but important part. It holds the striker spring, which is this guy over here, in place around the striker assembly. The critical dimensions are the thin diameter that fits around the striker, the outer diameter that holds the spring, and the locking grooves that keeps the cups secured together. If the cup should crack or not seat correctly, the striker spring may not stay aligned. This can cause light primer strikes or a failure to fire. Normal wear could include small cracks in the polymer cups or deformation from repeated compressed cycles. All right, now we got go to the next, the spring-loaded bearing, and that helps control the extractor tension and interacts with the striker safety system. Its critical dimensions include its overall length and diameter, which must match the slide channel precisely. If it's too short or damaged, extractor tension can change. That may cause failures to extract spent casings. Normal wear might include finish wear or a slight deformation from constant spring pressure. Now we're going to go to the extractor plunger, which works with the extractor to remove spent casings from the chamber. The most important dimensions are its length, diameter, and the flat or rounded contact surfaces that press against the extractor. If it becomes worn or bent, the extractor may not grip the casing firmly. This can lead to failure to extract, stovepipe malfunctions. Over time, the plunger may show surface wear or slight mushrooming at contact points. Finally, we have the rear rail, which supports and guides the slide as it moves back and forth. The critical dimensions include the height, thickness, spacing, and alignment from the front rails. If the rails are out of spec or worn unevenly, the slide may bind or tilt during cycling. That could reduce reliability and cause feeding problems. Normal wear on the rear rails usually show as finished wears on the top edge and slight polishing from the side contacts. So in conclusion, each of these parts plays an important role in the safe and reliable operations of the PSA dagger. Even small changes in critical dimensions can affect function. Most failures happen because of wear, poor polish, or poor installation, or manufacturing defects. Regular inspections and maintenance help prevent these problems and can keep the firearm operating safely and consistently. So let's go to part 3, I believe it is. Let's see. First, a gunsmith should complete formal education in firearms technology. So this includes training in firearm safety, blueprint reading, and proper tool use. Understanding how striker fire systems operate is crucial. A gunsmith should also train in measuring techniques using calipers and micrometers to verify critical dimensions like rear heights, spring lengths, and locking surfaces and engagement surfaces. Improper measurements or forcing parts into place can damage rear springs or locking surfaces. Hands-on training under supervision is especially important when working with small parts like striker spring cups or extractors assemblies, since these components are easy to lose, crack, or install incorrectly. Proper armor certificate courses, SDI, for pistols are also highly recommended because the PS Dagger shares similar internal designs as the block pattern. Now identify additional components that interact with the 6 selected parts. The locking block directly interacts with the barrel lug and a slide right there. When the pistol fires, the barrel and slides move rearwards together briefly before the barrel unlocks from the locking block. It also interfaces with frame pins that secure it in place. The trigger spring works with the trigger bar right here and the trigger ball housing and connector. The striker spring cups interacts with the striker spring cups with the striker. Striker spring cups interacts with the striker spring, and the striker sleeve. The spring load bearing here interacts with the safety system at the integration. So you got the plunger here, you got the extractor plunger, you got the extractor over there. All right, so for this video, I'm going to choose the striker spring right here as a component to estimate the replacement time. A trained gunsmith should be able to replace the trigger spring in approximately 10 to 20 minutes, assuming no complications. This includes safety unloading of the firearm, disassembling the firearm, removing the trigger housing, replacing the spring, and reassembling and function testing the pistol. Specialty tools required will include a Glock-style armor punch for the frame pins, a bench block to support the frame, needle nose pliers for handling the spring, eye protection since small springs can launch unexpectedly, and no advanced machine tools are required for the specific replacement, but precision and proper technique is essential to avoid bending the trigger bar or damaging it. Well, let's just show, as you can see, let's do the first thing first, put it all together, clear it, nothing in the chamber, only dummies in the magazine. Alright, let's go through the 8 steps of operation. First one is feeding. Feed the magazine into the gun. Next is chambering. Well, so as you put this in, the magazine catch the magazine so it won't fall out. Alright, so now it's chambered. The extractor will grip the round by the base. Alright, now we'll pull. Then you got the safety here. The safety works. The trigger safety. Oh, I'm sorry. Trigger safety works. So you gotta pull it from the top and can't. Alright, so now let's pull. Alright, now as you're pulling it, it pulls the striker spring back. And the striker, and once it breaks, once the sear lets it go, the striker goes forward, hits the primer goes off, and that's your firing. And then the projectile will leave the casing through the barrel out to whatever you aimed at. Alright, so now, and that's, alright, I got a double feed. There you go. Hey, these no grounds. Anyway, so the extractor grab onto the rim, and it pulled the casing out of the chamber. As it's pulling it out, it hits the injector, and that flings it out and out of the. It hits the injector. The extractor pulls the round out, hits the injector, and the rank flies out, and then, as you see. And as the slide goes forward, it picks up the next round, puts it up into the chamber, and then you're cocked. So now you're cocked. As it's, I know I'm all over the place. I'm sorry, but as it goes up into the chamber, it's locked. So that's the locking part. Then as you fire it, the slide will move back, will unlock. Then you got the injecting, or the extracting, the ejecting, and then follow back with the feeding, cocking, and locking. So I think I got that all covered. All right. Alright, I'm back. Let's do a function check. So, first thing I'm going to check for, make sure, first thing I'm going to check for is make sure the trigger safety works, and it does. Make sure it fires. There's the firing. Let's check the reset. Hope you heard the reset there. it's firing. Just make sure nothing in the magazine. Pull back. The last round hold open works. Alright. Function test. Still nothing in there. Got 30 rounds. Alright. Make sure chambers. Alright. Let's make sure this the safety trigger safety still works. Alright. See. Alright. Hold. Eject it. Reload. Now kept it on the safe resets. Resets. Fires. Ejects. Rechambers. Resets. Alright. And it holds open. Alright. So I think that's it for this week.